What's up, everybody? Good morning. This is a video on the distance between 2 points. And we're gonna use like the picture of those points on the graph with this distance formula to be able to actually calculate distance. And we'll use it in solving like geometric shapes and determining like what sort of shape we actually are talking about. So first of all, what I'm gonna do is I'm gonna actually recommend that you plot these 2 points on the graph. So follow me as I do that. We have -2, 3. So I'm gonna go 2 spaces to the left, the -2, and then I'm gonna go 3 up, and I'm gonna put a dot on my grid at that location. First number is left and right, second number is up and down. 4, -5 is the other coordinate. So the 4 means from the origin, 4 spaces to the right and 5 spaces down. And we're gonna put a dot right there. And I'm asking essentially, what is the distance? Not essentially, that is it. What is the distance between those 2 points? How long is that line segment? The distance formula specifically says y2 minus y1 is gonna be squared. That's the rise. So if you're gonna calculate up and down from 1 point and side to side from 1 point, like making a slope triangle, then the rise would be the y coordinate, the 2 y coordinates subtracted from each other. The x would be the run, and so in the distance formula, the x2 minus x1 would be the run between those 2 x coordinates. So if I have these 2 points, this would be my first x coordinate and my first y coordinate. That looks more like a y. This is my second x coordinate. There we go, my second y coordinate. And I can either put these 2 things into this formula, or I can like plot them on the graph, and then from plotting them on the graph, count boxes, count the amount of space that the 2 points rise and run. So let's do both. The first one is on the slope formula. I'm just literally gonna count spaces. I made the line segment between the 2 points, and then I'm gonna make the slope triangle between the 2 points and count how many spaces the rise is and how many spaces the run is. Technically, it's gonna be a negative slope because this is going down from left to right, but once you square, your answers will all be positive. So we're just gonna have a positive answer no matter what. Spaces, 1, 2, 3, 4, 5, 6, 7, 8. I get a rise of 8. And so my formula would say that has to be 8 squared. So it's technically like rise squared plus run squared, and then we'll square root. So my rise is 8, and I'm gonna square it going back to the graph. I have 1, 2, 3, 4, 5, 6 spaces. So in this problem, I'm gonna say my run is 6. That's what my run is on the graph. It's also 6. So we have the mathematics of 8 squared plus 6 squared. That's 64 plus 36. 64 plus 36 is 100, but we still have to square root our answer to actually get the distance. 100 square rooted, that'll be 10 for our answer. So here's what we have so far. We have plotted the points on the graph. We've used the graph to make a slope triangle. That would be count rise and run. And then using the Pythagorean theorem, throwing that out right now in this video, the Pythagorean theorem is what's happening here. Side squared plus side squared is hypotenuse squared. And we get an answer of 10. Stick around for part B, click forward in whatever like sequence is next, and I'll show you how to use the formula with these 2 points.